All right, now that we've looked at the average rate of speed for that example, I want to take a look at the average rate of change of a function in general. So, the average rate of change, of the function y equals f of x between x equals a and x equals b, because we need a starting value and an endpoint, is given by, and here I'll use ARC to represent average rate of change. Now it's going to be the change in y values divided by the change in x values. And remember, the y values are the function values, so this is going to be f of b minus f of a over b minus a. When we were looking at this as an average rate of speed, an average speed, when the function was a distance function, remember we took the difference of the two function values divided by the difference of the two x values that we were looking at on our interval. Now, this looks a little bit familiar maybe, even if we look at it like this, change in y over change of x. This should hopefully remind you of the slope of a line. When we have a line, if we look at the change in the y values between 2 points and the change in the x values between 2 points, and we take the quotient, that gives us the slope of that line. Now, our functions are not generally going to end up being straight lines, unless they're linear functions, of course. We're going to have different functions, but let's take a look at what this is graphically. If we have some sort of a function, let's just say it looks like this, and we're looking between two values of x, a and b, and so we're looking at these 2 points here. Let's see, a is the x value of the first point, b is the x value of the second point. Then this is going to be f of a, and then here we've got f of b. And so this quantity, the average rate of change, f of b minus f of a over b minus a, ends up being the rise over the run of the line that goes through these 2 points. We have a name for a line like that. It's called a secant line. A line that goes through 2 points on a graph is called a secant line. And so what we're dealing with here is we're dealing with the rise over the run of that secant line. So there's a geometric interpretation of what's going on here. This is going to come into play later when we look at instantaneous rates of change in Calculus 1. But for right now, what I want to do is I want to do some examples where our functions are just given to us by simple formulas. So let's find the average rate of change of the function f of x equals 3x minus 5. And we're going to do this looking at several intervals. We're going to look at the interval from 0 to 1. We're going to look at the interval from 3 to 5. And we're going to look at the interval from 4 to 10. So let's look at each of these intervals one at a time. we'll start with the interval from 0 to 1. So we know that the average rate of change is given by f of b minus f of a over b minus a. In this case, that's going to be f of 1 minus f of 0 over 1 minus 0. Now, f of 1 is our function value at 1. I'm going to put it in brackets. So f of 1 is going to be 3 times 1 minus 5 minus f of 0 is 3 times 0 minus 5, all over 1 minus 0 is just 1. Now let's evaluate each of those function values. 3 times 1 is 3, and then 3 minus 5 is negative 2. So we've got negative 2 minus 3 times 0 is 0, and 0 minus 5 is negative 5. So we've got negative 2 minus negative 5 over 1. That's going to be the same as negative 2 plus 5 over 1. Negative 2 plus 5 is 3, and 3 divided by 1 is 3. So the average rate of change on that first interval is going to be 3. Just a quick note, you've seen that I'm using brackets here. These brackets are completely unrelated to the brackets that we see here for interval notation. These brackets say that we're looking at the interval from 0 to 1, but these brackets here are just a set of grouping symbols. I don't want to use parentheses because we've already got parentheses here, so I'm using the brackets to distinguish between them so we can separate them in our minds. Let's go through and do the other two intervals now. Let's take a look at the interval from 3 to 5. So again, we've got the average rate of change, and it's going to be f of b, which in this case is 5, minus f of a, which is 3, over 5 minus 3. Now again, we have to evaluate that function at 5 and 3. So when we plug in 5, that's going to be 3 times 5 minus 5. And when we evaluate it at 3, it's going to be 3 times 3 minus 5, all over 2, because 5 minus 3 is 2. Now let's evaluate each of the things inside these brackets. In the first one, 3 times 5 is 15, and 15 minus 5 is 10. And then in the second one, 3 times 3 is 9, and 9 minus 5 is 4. So we've got 10 minus 4 over 2. 10 minus 4 is 6, and 6 divided by 2 is 3. So for that interval as well, the average rate of change is 3. Let's take a look at the third interval, the interval from 4 to 10. Hopefully you're getting the hang of this here. The average rate of change is going to be the difference in the function values, so f of 10 minus f of 4, divided by the difference of the x values, 10 minus 4. So when we substitute in 10, that gives us 3 times 10 minus 5. And when we substitute in 4, that's going to be 3 times 4 minus 5. And it'll all be over 6. Let's evaluate inside the brackets. 3 times 10 is 30, and 30 minus 5 is 25. Minus 3 times 4 is 12. 12 minus 5 is 7. So we've got 25 minus 7 over 6. 25 minus 7 is 18, and 18 divided by 6 is 3. So again, we end up with 3 for our average rate of change. Why did we get the same value for the average rate of change for all three of these intervals? Well, the answer is that our function was a linear function with a constant slope. The graph of this, f of x equals 3x minus 5, would look something like this And so anytime we're picking 2 points to look between, the slope of the secant line between those 2 points is just going to be the slope of the line that those points are on, which is going to end up being 3 in this case, because the slope of that line is 3. Please take a look at each of the examples linked below, because most of them are not linear equations, so you're going to see many situations where you're getting different average rates of change for different intervals. That's because they're changing at different rates on the different intervals.